Hello friends, welcome again to my YouTube channel Asma's Botany, and we have already discussed about the incomplete dominance, and it's one example in which only one character shows the incomplete dominance. And today we will discuss about the when two characters shows the incomplete dominance. Okay, so the term incomplete dominance means the dominant allele cannot completely mask the action of or the expression of the recessive allele. So the new phenotype develops. So it is the example when two characters shows the incomplete dominance. In first we saw that only one character, that is the color of flower in the Mirabilis chalapa we take, but here we take the two characters that shows both the characters shows the incomplete dominance. Okay, so here it was discovered in snapdragon Antirrhinum. Its botanical name is Antirrhinum majus, and it is also known as the dog flower. It is known as the dog flower because of the flower shape. It looks like the face of the dog, so it is known as the dog flower. Okay, then the two characters in this are the color of flower. First is the color of flower, and second is the shape of leaf. In the color of flower, the flower can either be red or white in color, but it is incomplete dominant. So if both the alleles, the red and white color allele, are present together in the heterozygous condition, then the pink flower is produced. Okay, so it is because of the incomplete dominance. Okay, in this second character, that is the shape of leaf. The leaf can be broad or narrow, and also intermediate leaf also be produced because of the when the both the alleles, the broad leaves which are broad or the dominant allele and the recessive allele present together in the heterozygous form, then the leaves produced is the intermediate in size because of the incomplete dominance, because the dominant allele, that is the broad allele, cannot completely mask the expression of narrow leaf, the recessive character. So the leaves are not broad, intermediate. Here the flower is not red, pink in color. Okay, so now we discuss about the cross, which is based when we take the two characters in which shows the incomplete dominance. Okay, so we see that the two characters are the color of flower and the shape of leaf. So here we take the one parent, that is in this the parent have the red flowers and broad leaves. Okay, it is red flower, and here is the white flower and narrow leaves. So we take the parents, that is the must be homozygous. Okay, means, and then homozygous means what? Both the alleles are equal. Okay, both the alleles are equal, not recessive allele is not present. Okay, only the red color allele is present and only the broad allele is present, and here only white allele is present. Color allele is completely absent. It is not heterozygous, it must be homozygous. Then we form the gametes. In this gametes, after the gametes, we get the F1 generation. In the F1 generation, you see that the flower is pink in color and intermediate leaves are produced because of the incomplete dominance, because this dominant allele this red color flower allele cannot completely mask the action or expression of the recessive allele, that is the flower white color flower allele. Okay, and the broad color leaves character, dominant character, cannot completely mask the action of or expression of the recessive character, that is the narrow leaves. So the leaves are intermediate in size. Remember it. Okay, then we will do the selfing. Selfing means to get the F2 generation. You know what is the meaning of selfing and what is the difference between the selfing and cross. Selfing means two plants with same genotype are made to reproduce, and cross means the two plants with distinct or different genotypes are made to reproduce. Okay, so here is the selfing. So the two parents have the same genotype. Okay, this is the same to this, both are same. Then we form the gametes. I have already discussed about the gamete formation method or the formula, the forking method and the formulas. Okay, then we will get the F2 generation. In this F2 generation, you see the 4 gametes, and here is the 4 gametes. Okay, then we will form the checkerboard or Punnett square. In this you shall see the phenotype and genotype of this. Okay, so if you see the genotype and phenotype, so if you see the phenotype, you see that the phenotype is deviate from the 9:3:3:1, and 9:3:3:1 is the phenotype of the Mendel's law of dihybrid cross of the Mendel. Okay, in the pea plant, in the garden pea plant, but it is deviate from this and it is similar to the genotype and it is changed. You can say it is changed because of the incomplete dominance. Okay, incomplete dominance, so this phenotype is changed. Now you can see in this, if we follow the Mendel's law, then it must be the red color flower and leaves must be the broad. Yes, leaves must be the broad, but it is the incomplete dominance, so here the leaves are intermediate in size, and here the flower are pink in color and broad leaves are produced. So due to the incomplete dominance, there will be change in the phenotype, and it is because of the incomplete dominance. But the genotype ratio is same means what? In comparison to the Mendel's result, Mendel's genotype. Okay, that's it. I hope you understand, and if you like the video, please like it and press the like button and subscribe to my channel Asma's Botany, and thank you.